Welcome to Shanti-Peace for Mathematics. This video is based on finding the Fourier series of the function f of x is equal to mod x in the interval minus pi to pi if it is a periodic function with the period 2 pi. To see the graph of this function, the graph of this function is look like this, and it is the periodic, so that's why the same graph you will get over the entire real line. And this is a periodic function. You can just see that it is called the triangular waves. So this is known as the triangular waves. So we are calculating the Fourier series for triangular waves. We know that the Fourier series definition is f of x is a0 by 2 plus summation n running from 1 to infinity an cos n x plus bn sin n x is there, where we need to calculate this Fourier coefficients. The value of a0 that we know it is 1 upon pi minus pi to pi, it is mod x dx. And you know that the function f of x is equal to mod x is an even function due to f of minus x is minus of f of x will be mod of x, which is f of x. So it is an even function. So if it is even function and the integration is from minus pi to pi, so we can write down this is actually 0 to pi 2 times mod of x dx, mod of x dx. But mod in the interval 0 to pi it is already x, so that's why it is 2 by pi 0 to pi x dx you will have. And if you integrate this x, we can have 2 by pi integration is x square by 2 0 to pi. So finally we will have 2 will get cancelled out, 1 pi is also cancelled out, we will have the pi answer. So value of a0 is a pi. Now an we calculate, which is again 1 upon pi minus pi to pi f of x cos nx dx. If I substitute this value of f of x, which is mod x, so it is cos nx dx, and this is an even function, this is also an even function, so that's why we can say it is 1 upon pi 0 to pi, it is 2 times x cos nx dx. Due to the in the interval 0 to pi the mod of x is actually x. And if I use the integration by parts here, we have x into sin nx upon n minus the derivative of x is 1, and the integration of this quantity will be cos nx upon n square, and this will become plus. The integration is from 0 to pi. Now to substitute pi, we know that the sin n pi is 0. So the first value is 0. If I substitute here, then we'll have cos n pi upon n square minus 0 into anything will become 0. Here if I substitute 0, then it will have 1 upon n square. And we know that the cos n pi is minus 1 raised to n. So finally the answer is 2 by pi minus 1 raised to n minus 1 upon n square. And for the bn, that we can have 1 upon pi minus pi to pi f of x, which is mod of x sin nx dx is there. Now this x is an even function and this is an odd function, and we know that the even into odd function is an again odd function, and the integration is from minus pi to pi. So the value of this bn will become 0 for any n running from 1 to infinity. Hence, your Fourier series we can write down as a0 by 2 plus summation n running from 1 to infinity an cos nx is there, but because bn is 0, and to substitute the value of a0, which is 2 by pi plus summation n running from 1 to infinity, the value of an which we have calculated in the previously, which is 2 by pi minus 1 raised to n minus 1 upon n square into cos nx. This is the required answer to calculate the Fourier series of the function f of x is equal to mod x. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in the comment box below. See you next video. Till then, bye bye, sayonara.